IPsec VPN. IPsec is a vendor a suite of protocols used to secure IP communications, authenticates or encrypts packets using the following protocols: Internet Key Exchange, Encapsulation Security Payload. Provides both data integrity and encryption. Authentication header only provides data integrity, not used by FortiGate. For NAT traversal, encapsulation security payload is a UDP encapsulator. Internet Key Exchange Review uses UDP, that is User Datagram Protocol port 500 and UDP port 4500 when crossing NAT. Negotiates the tunnel's private keys, authentication and encryption. One IPsec SA per traffic direction. Phases: phase 1 main mode and aggressive mode, phase 2 quick mode. Site-to-site VPN is also known as point-to-point VPN. IPsec is a vendor-neutral standard of set of protocols that is used to join two physically distinct LANs. The local area networks are joined if they were a single logical network despite being separated by the internet. In theory, IPsec does support null encryption. That is, you can make VPNs that don't encrypt traffic. IPsec also supports full data integrity, but does that provide any advantages over plain traffic? No one can trust traffic that may have had an attack injected by an attacker. Rarely do people want data sent by an unknown source. Most people also want private network data, such as credit card and transactions and medical records, to remain private. Regardless of the vendor, IPsec VPNs almost always have settings that allow them to provide the important benefits: authentications to verify the identity of both the ends, data integrity to prove that encapsulated data has not been tampered with as it crosses a potentially hostile network, confidentiality to make sure that only the intended recipient can read the message. What is the IPsec protocol? Multiple protocols that work together. AH provides integrity but not encryption. AH is defined in the RFC, but it's not used by the FortiGate. Port numbers and encapsulations vary by network address translations. If you're pausing, IPsec is a suite of separate protocols and includes Internet Key Exchange, is used to authenticate peers' exchange of keys and negotiate the encryption and checksums that will be used essentially in it is the control channel. Authentication header contains the authentication header, the checksums that verify the integrity of the data. Encapsulation security payload is the encapsulated security payload. The encrypted payload essentially the data channel. So if you need to pass IPsec traffic through your firewall, remember following just one protocol or port number is usually not enough. Note that the IPsec RFCs mentions, however, Authentication header does not offer encryption and important benefits. So authentication header is not used by FortiGate. As a result, you don't need to allow the authentication header internet protocol. To make a VPN, you must configure matching settings on both ends, whether the VPN is between two FortiGate devices, a FortiGate and a FortiGate client, or a third-party device and a FortiGate. If the settings don't match, tunnel setup will fail. Encapsulation and other protocols wrapped inside IPsec. What's inside varies by mode, transport mode and tunnel mode. Negotiations like SSL and TLS, authentication, handshake to exchange keys and settings. IPsec provides services at the IPNet layer. During the tunnel establishment, both ends negotiate the encryption and authentication algorithms to use. After the tunnel has been negotiated and is up, data is encrypted and encapsulated into the ESP packets. ESP encapsulation What is encapsulated? Depends on the encapsulation mode being used. IPsec can operate in two modes, transport mode and tunnel mode. Transport mode directly encapsulates and protects the fourth layer and above. The original IP header is not protected and no additional IP header is added. Tunnel mode is a true tunnel. The whole IP packet is encapsulated and a new IP header is added at the beginning. After the IPsec packet reaches the remote LAN and is unwrapped, the original packet can continue on its journey. Note that after you remove the VPN related headers, a transport mode packet can't be transmitted any further. It has no second IP header inside, so it's not routable. For that reason, this mode is usually used only for end-to-end VPNs. What is IKE? IKE means Internet Key Exchange. Uses UDP port 500. If NAT is enabled, in a NAT scenario, IKE uses UDP port 4500. IKE establishes an IPsec VPN tunnel. FortiGate uses IKE to negotiate with the peer and determine the IPsec Security Association. The IPsec Security Association defines the authentication, keys, and settings that will be used to encrypt and decrypt that peer's packets. It is based on the Internet Security Association and Key Management Protocol. IKE defines two phases, phase 1 and phase 2. There are two IKE versions, IKE v1 and IKE v2. Even though IKE v2 is a newer version and features a simpler protocol operation, the lesson will focus on IKE v1 only because of its much wider adoption. Negotiation. IKE allows the parties involved in a transaction to set up their SAs. In order to create the IPsec tunnel, both devices must establish their SAs and secret keys, which are facilitated by the IKE protocol. The IPsec architecture uses SAs are the basis of the building security functions into IPsec. An SA is simply the bundle of algorithms and parameters being used to encrypt and authenticate data traveling through the tunnel. In normal two-way traffic, this exchange is secured by a pair of SAs, one for each traffic direction. Essentially, both sides of the tunnel must agree on the security rules. If both sides cannot agree on the rules for sending data and verifying each other's identity, then the tunnel will not be established. SAs expire and need to be renegotiated by the peers after they have reached their lifetime. IKE uses two distinct phases, phase 1 and phase 2. Each phase negotiates different SA types. The SA negotiated during phase 1 is called Internet Key Exchange SA, and the SA negotiated during phase 2 is called the IPsec SA. IKE SAs are used for setting up a secure channel to negotiate IPsec SAs. IPsec SAs are used for encrypting and decrypting the data sent and received respectively through the channel. VPN topologies. Remote users connect to corporate resources. Remote access VPNs are used when internet users need to securely connect to the office to access corporate resources. The remote user connects to a VPN server located on the corporate premises, such as FortiGate, to establish a secure channel. After the user is authenticated, FortiGate provides an access to the network resources based on the permissions granted to that user. In a remote access, VPN FortiGate is usually configured as a dial-up server. You will learn more about dial-up VPNs in this lesson. The IP address of the remote internet user is usually dynamic because the FortiGate does not know the IP address of the remote user. Only the remote user can initiate a VPN connection request. On the remote user side, VPN client such as the FortiClient is needed. FortiClient must be configured to match the VPN server settings and takes care of establishing the tunnel as well as routing the traffic destined to the remote site through the tunnel. In addition, one remote access VPN configuration on your FortiGate can be used for many remote users, and for each of them, a separate tunnel is established. VPN topology site to site. Site to site VPN is also known as LAN to LAN VPN. A simple site to site deployment involves two peers communicating directly for connecting two networks that are located at different offices. When more than two locations need to be connected, a hub and spoke topologies can be used. In hub and spoke, all clients connect through a central hub. In the example shown on this slide, the client spokes are branch office FortiGate devices. For any branch office to reach another branch office, its traffic must pass through the hub. One advantage of this topology is that the configuration needed is easy to manage. Another advantage is that only the FortiGate at HQ must be very powerful because it handles all tunnels. Simultaneously, while the branch office FortiGate devices require much less resources because they maintain only one tunnel. One disadvantage is that communications between branch office through HQ is slower than in a direct connections, especially if your HQ is physically distant. Also, if the FortiGate HQ5, VPN failure will be company-wide. In a mesh topology, you can connect FortiGate devices directly and therefore bypass HQ. Two variations of mesh topology exist, full mesh and partial mesh. Full mesh connects every location to every other location. The higher the number of FortiGate devices, higher the number of tunnels to configure of each FortiGate device for a total of 20 tunnels. This topology causes less latency and requires much less HQ bandwidth than hub and spoke, but requires each FortiGate to be more powerful. Partial mesh attempts to compromise, minimizing required resources, but also latency. Partial mesh can be appropriate if communication is not required between every location. However, the configuration of each FortiGate is more complex than in a hub and spoke. Routing especially may require extensive planning. Generally, the more locations you have hub and spoke will be cheaper, but slower than a mesh topology. Mesh places less strain on the central location. It's more fault tolerant, but also more expensive. VPN topologies comparison, hub and spoke, partial mesh, and full mesh. Easy configurations, moderate configuration, complex configurations, few tunnels, medium number of tunnels, many tunnels, high central bandwidth, medium bandwidth in hub sites, low bandwidth, not fault tolerant, some tolerant, fault tolerant. To review the slide shows the high level of comparison of VPN topologies. You should choose the topology that is most appropriate to your situations. Easy, we have the comparisons between the hub and spoke, partial mesh and full mesh. Easy configurations and moderate configuration, complex configurations, few tunnels, medium number of tunnels, many tunnels, high central bandwidth in hub and spoke, medium bandwidth in hub site in partial mesh, and low bandwidth in full mesh. Not fault tolerant in hub and spoke, some fault tolerance in partial mesh, and fault tolerant in full mesh. Low system requirements on an average, but higher center. Medium system requirements, high system requirements, scalable, somewhat scalable, difficult to scale. No direct communications between spokes, direct communications between some sites, and direct communications between all sites. Auto discovery VPN. Each VPN topology has its advantages and disadvantages. Auto discovery VPN is a FortiGate feature that achieves the benefits of a full mesh topology with the easier configuration and scalability benefits of hub and spoke and partial mesh topologies. First, you add the VPN configuration for building either a hub and a spoke for a partial mesh topology to the FortiGate devices. Then you enable auto discovery VPN on the VPNs. Auto discovery VPN dynamically negotiates tunnels between spokes without having them pre-configured to get the benefits of a full mesh topology. Auto discovery VPN requires a dynamic routing protocol running over the IPsec tunnel so that spokes can learn the routes to other spokes after the dynamic VPNs negotiate. This is an auto discovery VPN configurations and example. Here on there are two locations. There are more than 2 locations, that is Boston, New York, Chicago, Paris, and London. Each locations we have the firewall. Then we had two additional firewalls, that is Hub 1 and Hub 2, which is related to auto discovery receiver enabled, auto discovery sender enabled, and auto discovery forwarder enabled. Traffic from Boston to London will trigger the dynamic negotiation of a direct VPN between both sides. Which VPN topology does not allow direct communications between spokes, hub and spoke? Which VPN topology is the most fault tolerant? Full mesh. Site-to-site VPN configurations. IPsec wizard. When you create an IPsec tunnel on the graphical user interface, FortiGate redirects you to the IPsec wizard. The wizard simplifies the creation of the new VPN by walking you through a 3 to 4 step process. The first step is to select a template type. If you want to manually configure your VPN, you can select custom as template type, upon which FortiGate takes you directly to the phase 1 and phase 2 settings of the new VPN. If you want the wizard to configure VPN for you, then select the template type, that site-to-site, hub and spoke, or remote access that best matches your VPN. After that, the wizard will ask you for key information such as the remote gateway information, authentication method, interfaces involved, and subnets. Based on the input you provided, the wizard applies one of the pre-configured IPsec tunnel templates compromising IPsec with phase 1 and phase 2 settings and other related firewall address objects, routing settings, and firewall policies needed for the new tunnel to work. In addition, the wizard shows a network diagram that changes based on the net input provided. The purpose of the diagram is for the administrator to have a visual understanding of the IPsec VPN deployment that the wizard will configure based on the input received. At the end of the wizard provides a summary of the configuration changes made in the system and that the administrator can review if needed. If you are new to FortiGate or don't have much experience with IPsec VPNs, using the IPsec wizard is recommended. You can later adjust the configurations applied by the wizard to match your specific needs. Using IPsec wizard for FortiClient VPN, a common use of the IPsec wizard is for configuring remote access VPN for client users. The wizard enables Internet Key Exchange modes config, XAuth, and other appropriate settings for FortiClient users. You will learn more about Internet Key Exchange mode config and XAuth in this lesson. The images on this slide shows the 4-step process used by the IPsec wizard for assisting the administrator and the client for the FortiClient of the VPN configuration. Policy-based compared to route-based. The Generally, route-based VPNs offer more control and flexibility. The features are for operation mode, L2, the policy-based and route-based. In policy-based, NAT and transparent, only NAT in the route-based. L2 TP over IPsec is the policy based is S. In route based is also L2 TP and over IPsec is used. GRU over IPsec is no in policy based, but yes in the route based. Routing protocols are not used in the policy based, and then routing protocols are used in the route based. Number of policies per VPN. One policy controls both traffic directions in policy based. Two policies, one for each directions. The IPsec the IPsec wizard uses one of the templates shown on this slide when applying the configuration for the new IPsec tunnel. You can review the settings of the template by selecting the template, then clicking view. The template settings cannot be changed. Policy based compared to route based. Route based traffic must be routed to the IPsec virtual network interface. Traffic must be routed to the IPsec virtual network interface. Usually two firewall policies with the action set to accept are required. Policy based. One firewall policy with the action set to IPsec is required. By default, hidden on the guide to show. Manual VPN configuration, that is custom phase one. Phase one takes place when each peer of the tunnel, the initiator and the responder connects and begins to the setup to the VPN. The initiator is the peer that starts the phase one negotiation, while the responder is the peer that responds to the initiator request. When the peer first connects, the channel is not secure. An attacker in the middle could intercept unencrypted keys. Neither peer has a strong guarantee of the other's identity. So how can they exchange sensitive private keys? They can't. First, both peers create a secure tunnel. They will use the secure tunnel to protect strong authentication and negotiate the real keys for the tunnel later. Phase one, how it works. Authentication peers, enable to create route-based, disabled to create policy-based. The purpose of the phase one is to authenticate peers and set up a secure channel for negotiating the phase two SAs that are later used to encrypt and decrypt the traffic between the peers. To establish this secure channel, the peers negotiate a phase one SA. This SA is called the Internet Key Exchange SAs and is bidirectional. To authenticate each other, the peers uses two methods: pre-shared key or digital signature. An additional authentication method, XAuth, can also be enabled to enhance authentication. In IKE V1, there are two possible modes in which the IKE SA negotiation can take place, main and aggressive mode. Settings on both ends must agree, otherwise phase 1 negotiation will fail and both IPsec peers won't be able to establish a secure channel. At the end of the phase 1, the negotiated IKE SA is used to negotiate the DH keys that will be used in phase 2. The DH uses the public key that both ends know, plus a mathematical factor called nonce. In order to generate a common private key with DH, even if an attacker can listen into the messages containing the public keys, they cannot determine the secret key. Phase 1 configuration is broken down on the guide into 4 sections: network authentications, phase 1, proposal, and XAuth. You will learn more about the settings available on each sections. For some of them, there will be a separate slides to discuss in more detail. Phase 1 configuration is broken down on the guide into 4 sections. The section shown on this slide corresponds to the network settings. The section includes the settings related to the connectivity of the IPsec tunnel. IP version. Select the IP versions to use for the IPsec tunnel. Note that this only defines the IP version of the outer layer of the tunnel. IP versions. Select the IP version to use for the IPsec tunnel. Note that this only defines the IP version of the outer layer of the tunnel. The packets being encapsulated can be IPv4 and or IPv6, and their IP version is defined in the phase 2 selectors. Remote gateway defines the type of the remote gateway. There are 3 types: static IP address, a dial-up user, and dynamic DNS. You will learn more about these types in this lesson. IP address of the remote gateway. The field appears only when you select static IP address as remote gateway. Interface refers to the interface where the IPsec tunnel terminates on the local FortiGate. Usually, this is the interface connected to the internet or the WAN. You need to make sure there is an active route to the remote gateway through this interface. Otherwise, the tunnel won't come up. Local gateway will enable the settings when the interface where the tunnel terminates has multiple addresses assigned and you want to specify which address to use for the tunnel. When you enable the setting, you will see 3 options: primary IP, secondary IP, and specify. And select specify if you want to use an IP address different from the primary or secondary IP address. Mode config enables automatic configurations through IKE. FortiGate access IKE mode config client. When you enable mode config and you set remote gateway to either static IP address or dynamic. When you enable mode config and you set remote gateway to either static IP address or dynamic DNS. If you set remote gateway to dial-up user, FortiGate acts as IKE mode config server and more configuration options appear on the guide. You will learn more about config in this lessons. phase 1 network. Below are the other options available on the GUI or the network selections. NAT traversal controls the behavior of NAT traversal. You will learn more about NAT traversal in this lesson. Keep alive frequency. When NAT traversal is enabled, FortiGate will send keep alive probes to at the configured frequency. Dead pure detection. Dead pure detection is used to detect dead tunnels. There are 3 DPD modes. On demand is the default mode. You will learn more about DPD in this lesson. Forward error correction is a technique that can be used to reduce the number of free transmission in IPsec tunnels established over unreliable links at the expense of using more bandwidth. FEC can be enabled on egress and ingress, and it is only supported when IPsec hardware offloading is disabled. You will learn more about IPsec hardware offload in this lesson. Advanced device creation when enabled. Kernel creates an interface for every dial-up client. For deployments with a large number of dial-up clients, disable device creation to achieve higher performance. Aggregate member, FortiGate allows you to aggregate multiple IPsec tunnels into a single interface. Enable this option if you want the tunnel to become the aggregate member. Phase 1 network remote gateway. You have 3 options when configuring remote gateway types of your VPN. You have 3 options when configuring the remote gateway type of your VPN: dial-up user, static IP address, and dynamic DNS. Dial-up user is used when the remote peer's IP address is unknown. The remote use peer whose IP address is unknown access the dial-up client. And this is often the case for branch offices and mobile VPN clients that use dynamic IP addresses and no dynamic DNS. The dial-up client must know the IP address for FQDN of the remote gateway, which acts as the dial-up server, because the dial-up server doesn't know the remote peer's address. Only the dial-up client can initiate the VPN tunnel. Usually, dial-up clients and or remote and mobile employees with FortiClient on their computer or handheld devices. You can also have a FortiGate devices acting as the dial-up client for a remote office. One dial-up server configurations on your FortiGate can be used for multiple IPsec tunnels from many remote offices or users. Static IP address or dynamic DNS are used when you know the remote peer's address. If you select static IP address, then you need to provide an IP address. If you select dynamic DNS, then you need to provide fully qualified domain name, and make sure FortiGate can resolve that FQDN when both peers knows the remote peer address. This is the remote gateway on both peers is set to static IP address or dynamic DNS, then any peer can initiate the VPN tunnel. Note that in dial-up setup, the dial-up setup client is just a VPN peer with the remote gateway set to static IP address or dynamic DNS. When setting your VPN, you can combine different types of remote gateways for obvious reasons. A tunnel in which both peers has the remote gateway set to dial-up user won't work. Phase 1 network IKE mode config. IKE mode config is similar to DHCP because a server assigns network settings such as IP address, netmask, and DNS servers to clients. This assignment takes place over IKE messages. When you enable mode config on a FortiGate acting as dial-up server, it pushes network settings to dial-up clients. The dial-up clients are usually FortiClient peers, but they can also be FortiGate peers. For IKE mode config to work, you must enable the feature on both peers. On FortiClient, mode config is enabled by default, but on FortiGate, you need to manually enable it. Note that the IKE mode config settings are only displayed on the GUI when remote gateway is used to dial-up user. On the FortiGate acting as dial-up client, you can check mode config option on the GUI, but the additional settings won't be displayed. Phase 1 network, NAT traversal. The ESP protocol usually has problems crossing devices that are performing NAT. One of the reasons is that ESP does not use port numbers like TCP and UDP due to differentiate one tunnel from another. To solve this, NAT traversal was added to the IPsec specifications. When NAT-T is enabled on both the ends, peers can detect any NAT device along the path. If NAT is found when the following occurs on both peers: IKE negotiation switches to using UDP port 4500. ESP packets are encapsulated in UDP port 4500. So if you have two FortiGate devices that are behind, for example, in ISP modem that has NAT, you will probably need to enable the settings. When the NAT traversal setting is set to forced, UDP port 4500 is always used, even when there is no NAT device along the path. When NAT-T is enabled, the keep alive frequency option shows the interval at which FortiGate sends keep alive probes. You need for NAT-T when there is one or more others routers along the path performing NAT. The purpose of the keep alive probes is to keep the IPsec connections active across those routers along the path. After the IPsec SCAs of the tunnel are negotiated, therefore, the tunnel is configured up the peers usually. After the IPsec, therefore, the tunnel is considered up. The peers usually don't negotiate another IPsec SCAs until it expires. In most cases, IPsec SCA expires every few hours. This means that if there is a network disruption along the path of the tunnel before the IPsec SCA expires, the peers will continue to send traffic through the tunnel, even though the communications between the sites is disrupted. When the DPD is enabled, dead peer detection is enabled. dead peer detection probes are said to detect a failed or dead tunnel and bring it down before its IPsec ACAs expire. This failure detection mechanism is very useful when you have redundant path to the same destination and you want to fail over to a backup connection when the primary connection fails to keep the connectivity between the sites up. FortiGate supports three DP dead peer detection modes, that is on demand, on idle, and disabled. On demand, FortiGate sends DPD probes if there is only outbound traffic through the tunnel, but no inbound. Because network applications are usually bidirectional, observing only traffic on the outbound directions could be a indication of a network failure. On idle, FortiGate sends DPD probes when no traffic is observed in the tunnel, and idle tunnel does not necessarily mean the tunnel is dead. Avoid this mode if you have many tunnels because the overhead introduced by DPD can be very resource intensive. Disabled. FortiGate only replies to DPD probes received. FortiGate never sends DPD probes to the remote peer and therefore cannot detect a dead tunnel. The default DPD mode is on demand. In terms of scalability, the on demand is a better option than the on idle. Phase 1 authentication method. You will learn about the authentication sections on phase 1 configuration method. FortiGate supports two authentication methods, pre-shared key and the signature. When you select pre-shared key, both peers must be configured with the same pre-shared key. When you select signature, phase 1 authentication is based on digital certificate signatures. Under this method, the digital signature on one peer is validated on the presence of the CA certificate installed on the other peer. This is the local peer. You need to install both the local peer certificate and the CA certificate that is issued the remote peer certificate. Allows you to select IKE versions to use. When selecting versions too aggressive and main modes disappear because they don't apply to IKE v2. Mode refers to the IKE v1 mode. Two options are available, aggressive and main ID protections. You will learn more about these modes in this lesson. Phase 1 authentication modes. Phase IKE supports two different negotiation modes, main and aggressive. Which one should you use? To answer that question, we can analyze three categories: security, performance, and deployment. Security-wise, main mode is considered more secure because the pre-shared key hash is exchanged, encrypted, whereas it's aggressive mode, the hash is exchanged and encrypted, although the attacker would still have to guess on the clear text pre-shared key for the attack to be successful. The fact that the pre-shared key has been encrypted in main mode reduces considerably the chances of a successful attack. In terms of performance, aggressive mode may be a better option. This is because the negotiation is completed after only 3 packets are exchanged, whereas in main mode, 6 packets are exchanged. For this reason, you may want to use aggressive mode when agreed number of tunnels terminate on the same FortiGate device. Performance is a concern. Another use cases for aggressive mode is when there is more than one dial-up tunnel terminating on the same FortiGate IP address and the remote peer is authenticated using a peer ID because its IP address is dynamic. Because peer ID information is sent in the first packet in an aggressive mode negotiation, then the FortiGate can match the remote peer with the one correct dial-up tunnel. The latter is not possible in main mode because the peer ID information is sent in the last packet and after the tunnel has been identified. When both peers know each other's IP address for FQDN, that is fully qualified domain name, you may want to use main mode to leak advantage of its more secure negotiation. In this case, FortiGate can identify the remote peer by its IP address and as a result associate with it with the correct IPsec channel. Phase 1 proposal. You will learn about the phase 1 proposal sections on phase 1 configuration. The sections allows you to enable the different proposals that FortiGate supports when negotiating the IKE SA. You can combine different parameters to suit your security needs. You must at least configure one combination of encryption and authentication algorithms or several. Encryption, select the algorithm to use the encrypting. This section allows you to enable the different proposals that FortiGate supports when negotiating the IKE SA. You can combine different parameters to suit your security needs. You must at least configure one combination of encryption and authentication algorithms or several. Encryption, select the algorithm to use for encrypting and decrypting the data. Authentication, select the authentication algorithm to use for verifying integrity and authenticity of the data. Diffie-Hellman groups. Diffie-Hellman algorithm is used during IKE SA negotiation. The use of DH, the phase 1 is mandatory and can't be disabled. You must select at least one DH group. The higher the DH group number and the more secure the phase 1 negotiation is. However, the higher DH group number also results in a longer compute time. Key lifetime defines the lifetime of the IKE SA. At the end of the lifetime, a new IKE SA is negotiated. If the peer accepts a specific peer ID, type that same peer ID in this field. Phase 1 extended authentication. Phase 1 supports two types of authentication, pre-shared keys and the digital signatures. The XOR extension, sometimes called phase 105, forces remote users to authenticate additionally with their credentials, username and password. So additional authentication packets are exchanged. If you enable it, what is the benefit of strong authentication? When remote gateway is set to dial-up server, FortiGate acts as the authentication server, and XOR section shows the authentication server type options, PAP server and CHAP server and auto server. In the example shown on this slide, auto server is selected, which means that FortiGate automatically detects the authentication protocol used by the client. After you select the authentication server type, you configure how user group is matching is performed. There are two options, inherit from policy and choose. The latter is used in the example on this slide and allows you to select one of the user group available on FortiGate. Note that when you select choose, you need to configure a separate dial-up VPN for every group of users that require a different network access policy. The other ways to authenticate VPN users with XAuth is by selecting inherit from policy. When you select this option, FortiGate authenticates users based on their matching IPsec policy, and as a result, the configurations for controlling network access is simpler. That is, you control network access by configuring multiple policies for different user groups instead of configuring multiple tunnels for different user groups. The inherit from policy option follows a similar authentication approach used for SSL VPN remote users. You will learn more about SSL VPN in another lessons. When remote gateway is set to static IP address or dynamic DNS, FortiGate acts as the client and the XR section shows client option as type. You can then set the credentials that FortiGate uses to authenticate against the remote peer through XAuth. Phase 2, how it works. After phase 1 has established a secure channel to exchange data, and phase 2 begins. Phase 2 negotiates security parameters for two IPsec SAs or over the secure channel established during phase 1. ESP uses IPsec SAs to encrypt and decrypt the traffic exchanged between sites. Phase 2 doesn't end when ESP begins. Phase 2 periodically renegotiates IPsec SAs to maintain security. If you enable perfect forward secrecy, each time phase 2 expires, FortiGate will use DH to recalculate new secret keys. In this way, new keys are not derived from older keys, making it much harder for an attacker to crack the tunnel. Each phase 1 can have multiple phase 2s. When would this happen? For example, you may want to use different encryption keys for each subnet whose traffic is crossing the tunnel. How does FortiGate select which phase 2 to use? By checking which phase 2 selector matches the traffic. Phase 2 selectors. In phase 2, you need to define the encryption domain of your IPsec tunnel. The encryption domain refers to the traffic you want to protect with IPsec, and it is determined by your phase 2 selector configuration. You can configure multiple selectors to have more granular control over traffic. When you configure a phase 2 selector, you specify the encryption domain by indicating the following network parameters. That is local address and the remote address. As seen in this example shown on this slide, you can define IPv4 or IPv6 addresses using different address scopes when selecting named address or named IPv6. Address. FortiGate allows you to select IPv4 or IPv6 firewall address object respectively configured in the systems. Protocol, it is shown under the advanced section and it is set to all by default. Local port and remote port, it is also shown under the advanced section and it is set to all by default. The only applies to port based traffic such as TCP or UDP. You will learn more about the advanced section in this lesson. Note that after the traffic is accepted by a firewall policy, the traffic will be dropped before entering the IPsec tunnel if the traffic does not match any of the phase 2 selectors configured. For this reason, usually it's more tunnel if the traffic does not match any of the phase 2 selectors configured. For this reason, usually it's more intuitive to filter traffic with firewall policies. So if you don't want to use phase 2 selector filtering, you can just create one phase 2 selector with both local and remote address set to any subnet like in the example shown on the slide. Then use the firewall policies to control which traffic is accepted on the IPsec tunnel. In addition, phase 2 selector network parameters on both peers must match if the tunnel is point to point. That is when the remote gateway is not set to dial-up user. Phase 2 proposals. For every phase 2 selector, you need to configure one or more phase 2 proposals. A phase 2 proposal defines the algorithms supported by the peer for encrypting and decrypting the data over the tunnel. You can configure multiple proposals to offer more options on the remote peer when negotiating the IPsec SAs. Like in phase 1, you need to select a combination of encryption and authentication algorithms. Some algorithms are considered more secure than others. So make sure to select the algorithms that conform with your security policy. However, note that the selection of the algorithms have a direct impact on FortiGate IPsec performance. For example, 3DES is known to be much more resource intensive encryption algorithms than DES and AES, which means that your IPsec throughput could be negatively impacted. If you select 3DES as the encryption algorithm, also note that if you select null as the encryption algorithm, traffic is not encrypted. In addition, some encryption algorithms such as ChaCha20POL Poly 1305 are not supported for hardware offload. That is, if you have FortiGate appliance that contains network processor units, you can achieve higher IPsec performance if you select an algorithm that is supported for IPsec offload by your NP unit model, such as AES or DES. For list of supported encryption algorithms for IPsec hardware offloading, refer to this site, docs.fortinet.com. When configuring the phase 2 proposal, we can check the enable replay detection option to detect anti-replay attacks on ESP packets. Note that this is the local setting, therefore it is not included as part of the proposals presented by the peer during phase 2 negotiation. Also, if you enable perfect forward secrecy, FortiGate uses DH to enhance security during the negotiation of IPsec SAs. IPsec SAs are periodically negotiated to improve security, but when does that happen? It depends on the key lifetime settings configured on the phase 2 proposal. The expiration of the IPsec SAs is determined by the lifetime and threshold configured. By default, key lifetime is set to seconds. This means that when SA duration reaches the amount of seconds set as seconds, the SAs is considered expired. You can also set the key lifetime to kilobytes, upon which the SA expires after the amount of traffic encrypted and decrypted using that SA reaches the threshold set. Alternatively, you can select both as the key lifetime type, upon which FortiGate tracks both the duration of the SA and the amount of traffic. Then when any of the two threshold is reached, the SA is considered expired. Note that the key lifetime thresholds do not have to match for the tunnel to come up. When thresholds are different, the peers agree on using the lowest threshold value offered between the two. When IPsec SAs expire, FortiGate needs to negotiate new SAs to continue sending and receiving traffic over the IPsec tunnel. Technically, FortiGate deletes the expired SAs from the respective phase 2 selectors and installs new ones. If IPsec SA renegotiation takes too much time, then FortiGate may drop the interesting traffic because of the absence of active SAs. To prevent this, you can enable auto negotiate. When you do this, FortiGate not only negotiates new SAs before the current SAs expire, but it also starts using the new SAs right away. The latter prevents the traffic disruption by IPsec SA renegotiation. Another benefit of enabling auto negotiate is that the tunnel comes up and stays up automatically. Even when there is no interesting traffic, when you enable auto keep alive and keep auto negotiate disabled, tunnel will come up automatically unless there is interesting traffic. However, after the tunnel is up, it stays the way because FortiGate periodically sends keep alive packets over the tunnel. Note that when you enable auto negotiate, auto keep alive is implicitly enabled. On firewall policy for policy-based VPN, to remote port 3, that is VPN tunnel to VPN tunnel to remote need to select it for this IPsec VPN tunnel. IPsec hardware FortiGate supports two types of IPsec VPNs, route-based and policy-based. Policy-based is a legacy IPsec VPN that is only supported for backward compatibility reasons, and its use is not recommended for new deployments. Unless otherwise stated, all the IPsec VPN references on this lesson are for route-based IPsec VPNs. In route-based IPsec VPN, FortiGate automatically adds a virtual interface with the VPN. Configure routing and firewall policies for IPsec traffic in the same way you do for non-IPsec traffic, but you also can leverage the presence of multiple connections to the same destinations to achieve redundancy. Another benefit of route-based IPsec VPNs is that you can deploy variations of IPsec VPNs such as LT2P over IPsec and GRE over IPsec. In addition, you can also enable dynamic routing protocol for scalability purposes, the best path selection. Routes for IPsec VPN, dial up user and start. Although you can use the routing configurations needed for your IPsec VPN depends on the type of remote gateway configured. when the remote gateway is set to dial-up user and the add route is enabled. FortiGate automatically adds the static route for the local network presented by the remote peer during phase 2 negotiation. In addition, the route is added to the routing table only after phase 2 is up. If phase 2 goes down, the static route is removed from the routing table. When the remote gateway is set to dial-up user and add route is disabled, FortiGate does not add static routes automatically. In this case, a dynamic routing protocol is used between the remote peers to exchange routing information. When the remote gateway is set to static IP address or dynamic DNS, you need to configure static routes. When you configure the static route, you select the virtual interface of the IPsec tunnel as the outgoing interface. Firewall policies for IPsec VPN. You must configure at least one firewall policy that accepts traffic on your IPsec tunnel. Otherwise, the tunnel will not come up. When you configure firewall policies or non-IPsec traffic, the policy determines the direction of the traffic and initiates sessions. The same applies to IPsec traffic. For this reason, you usually want to configure at least 2 firewall policies for your IPsec VPN, one incoming policy and one outgoing policy. The incoming policy allows traffic initiated from the remote site, while the outgoing policy allows traffic to be initiated from the local network. Note that the policies are configured with the virtual tunnel interface as the incoming or outgoing interface. The IPsec monitor widget on the guide displays phase 2 informations only. If you want to get phase 1 information, you need to use the command line interface. The example on this slide shows the output for the get VPN like gateway command, which shows the detailed phase 1 informations, phase 2 status, on the guide dashboard, you can use the IPsec widgets to monitor the status of your IPsec VPN. The widget only shows phase 2 status of a tunnel and not the phase 1 status. You can also bring up or down individual tunnels and get additional details. When you bring up or down individual tunnels and get additional details. When you bring up or down tunnels using the IPsec widget, you are only affecting the phase 2 status of the tunnel and not its phase 1 status. If the tunnel is up, meaning phase 2 is up, the green up arrow is displayed next to its name. If it is down, then a red down arrow is displayed. The IPsec widget also displays the amount of data sent and received through the tunnel. When you right click of any of the columns, a menu is displayed. When a list of the columns are available, you can enable additional columns to get further details on the IPsec tunnels. Monitor IPsec routes. How can you make your IPsec VPN deployment more resilient? Provide a second ISP connections to your site and configure 2 IPsec VPNs. If the primary IPsec VPN fails, another tunnel can be used instead. There are 2 types of redundant VPNs, partially redundant and fully redundant. On one peer has 2 connections. Each VPN terminates on different physical ports. That way, FortiGate can use an alternative VPN on the other peer. Each VPN terminates on the same physical port. So the spoke is fault tolerant. Fully redundant, both peers terminate their VPNs on different physical ports. So they are both fully fault tolerant. Redundant VPN configurations. So how do you configure partially or fully redundant VPN? First, create one phase 1 for each path, one phase 1 for the primary VPN, and one for the backup VPN. You should also enable DPD on both ends. Second, create at least one phase 2 definition for each phase 1. Third, you must add at least one static route for each VPN. Routes for the primary VPN must have a lower distance than the backup. This causes FortiGate to use the primary VPN. It's available. If the primary VPN fails, when the FortiGate automatically uses the backup route, alternatively, you can use a dynamic routing protocol such as OSPF or BGP. Finally, configure firewall policies to allow traffic through both primary and the backup VPNs. Hardware offloading requirements. On some FortiGate models, you can offload IPsec encryption and decryption hardware to hardware. Hardware offloading capabilities and supported algorithms vary by processor type and model. By default, offloading is enabled for supported algorithms. You can manually disable offloading. Config VPN IPsec phase 1 interface. Edit to remote set NPU, offload, enable or disabled end. When configuring policy-based VPN, what options do you need to select for the action setting? IPsec. Which of the following statements about route-based VPN is correct? It usually requires 2 firewall policies, one for each direction. Interoperability with other vendors. Some vendors do not support quick mode selectors that are or contain subnets with different sizes. Expect different SAs for each pair of local and remote protected subnets. Solutions: define a different phase2 for each pair of subnets. Define only two phase2 and enable internet key exchange VN dynamic selector. FortiGate automatically creates a phase2 on demand. Config VPN IPsec phase1 or phase1 interface. Edit VPN name. Set mesh selector type subnet. Verifying the offload VPN hardware acceleration. NPU flag diagnose VPN tunnel list all IPsec tunnel. NPU flag indicates VPN offloading. NPU flag is equal to 0 means that ingress and egress ESP packets are not offloaded. NPU flag is equal to 01 means only egress ESP packets can be offloaded. Ingress ESP packets will be handled by the kernel. NPU flag is equal to 02 means only ingress ESP packets can be offloaded. Egress ESP packets will be handled by the kernel. NPU flag is equal to 03 means that both ingress and egress ESP packets will be offloaded. Is the tunnel not coming up? Check the configurations. Most connections fail because the configuration mismatches. Run the IKE real-time debug if possible on both sides. Diagnose VPN like log filter, DST address, diagnose debug applications IKE -1, diagnose debug enable. The output of the IKE real-time of debug is extensive. It provides the details of phase 1 and phase 2 negotiations, saving the output as recommended. Stop the real-time debug after troubleshooting. Diagnose debug reset, diagnose debug disable. Phase 2 real-time debug. Output of the real-time debug, common causes, common solutions. Tunnel is not coming up. Error, negotiation failure. Error, no SA proposal chosen. FortiGate using the wrong VPN. IPsec VIP configuration mismatch. Configuration mismatch, missing or wrong local ID. Check phases 1 and 2 settings. Check phases 1 and 2 settings. If there are more than one pre-shared key and dial-up VPNs with the same local gateway, use aggressive mode and the different local IDs. Which one of the following messages indicates that both ingress and egress ESP packets will be offloaded? NPU flag 3. If you enable NAT in the firewall policy for VPN, which of the following issues may occur? Quick mode selector may mismatch.